Hi, I'm Carl, and in this video we're going to have a look at questions 5 to 9 of section 3 of the green booklet. This is a question about electronegativity, and I've copied down the table that we were given. There are also a couple of paragraphs that talk about how a bond can be dipolar. It's worth reading those over first, before trying to answer the questions. First off, we have number 5, which says, of the following, the most polar bond will be a covalent bond formed between which atoms? And it gives us 4 options then. So as we know, each of these has an electronegativity value, and the most polar bond will have 2 atoms with the greatest difference in electronegativity. So it's worth just going through and working out what the different values are. So for A, we've got a bond between chlorine and fluorine, the difference in electronegativity. Then we can work that out by taking away 3.98 and 3.16. And that gives us an answer of 0.82. Option B then is between phosphorus and nitrogen. From the table we can get our values. For nitrogen it's going to be 3.04 and phosphorus it's going to be 2.19, and that's going to give us an answer of 0.85. C is between sulfur and oxygen, and that's going to be 3.44 minus 2.58, and that's going to give us an answer of 0.86. And then the last one is going to be carbon and chlorine, and that's going to be 3.16 minus 2.55, and that's going to give us a difference of 0.61. So that's the difference in the electronegativities for each of these combinations. The most polar bond will be formed between atoms that have the greatest difference, and therefore the answer for this one is going to be C. If we look at 6, then it says that in one part of a molecule there's a carbon-oxygen double bond, while in another part there's a nitrogen-hydrogen single bond, and I've drawn them out here. If these two parts of the molecule were sufficiently close together, what would happen? Well, the reason I drew this out is because we can have a look at what way the electrons are going to sit. And we're told about delta positive and delta negativity in the paragraphs, talking about a slight negative and a positive charge. So we know nitrogen is going to be more electronegative than hydrogen. So we can say this is going to be delta negative. It's going to have a slight negative charge. And this is going to be delta positive then. On the other side, we've got carbon and oxygen. Oxygen is more electronegative, so we're going to have a delta negative side and a delta positive side here. There's lone pairs of electrons on the oxygen. And because the oxygen overall is quite negative now with these lone pair of electrons too, this positive charge will be attracted to it. And that means that the attraction between the hydrogen bond, or the hydrogen atom in one bond, will be attracted to the atom, the oxygen atom in the other. And we can see here is literally just because of the difference in electronegativities. You get this attraction between the hydrogen and the oxygen. So that means that the answer for this one is going to be C. But to rule out the other ones, if we were looking at A, it says 2 hydrogen bonds would form involving all 4 atoms. And we could see that, if we had, say, carbon and oxygen here, and we had nitrogen and hydrogen here, this would be delta negative, this would be delta positive, this would be delta positive, and this would be delta negative. So you could say there'd be some sort of attraction here. And that's right, there are going to be dipole-dipole interactions here, but it's the attraction between the positive charge on the hydrogen here with the lone pairs of electrons on the oxygen, which forms a hydrogen bond. So that's the difference. B says an attraction to the nitrogen to the oxygen. Well, the nitrogen is negatively charged and so is the oxygen. They're not going to be attracted to each other, so we can rule out B as well. And finally, D says a repulsion between the carbon atom in one bond and the nitrogen atom in the other. So they're complementary in terms that one is positively charged and one is negatively charged. So we wouldn't really see a repulsion there. So that means that the answer for this one is C. Question 7 then says covalent bonds occurring in amino acids include that between an atom of carbon and nitrogen and an atom of sulfur and hydrogen. The positively charged ends of these 2 bonds would be, respectively, the atoms of what? So in this question, we want to work out, of the bonds that we're told about, which are going to be, the first one's going to be carbon, nitrogen, and the second one's going to be sulfur, hydrogen. Which ones are positives and which ones are negatives? So if we look at the table we have up here for carbon and nitrogen, comparing this, we can see that carbon is going to be electropositive relative to nitrogen. because nitrogen has a greater electronegativity value. So we can say that carbon is going to be the electropositive one, and this can be electronegative. So that sort of boils down our answer down to A or B. So is sulfur or hydrogen more electronegative? Well, we can see here that sulfur is more electronegative. So we can say this can be delta positive and this can be delta negative. Therefore, the positively charged ends of these bonds, respectively, will be C and H, or carbon and hydrogen. Means that the answer for 7 is going to be B. Question 8, then I've drawn out all the different versions of it, and it says of the following, the attractive interaction between atoms of these two molecules that are the same distance apart, which is what those 3 dots means, would be strongest in which one? So which bond that's formed here over this 3 dot distance is going to be the strongest, and this is question 8. So looking at A, we can see that we have what would be, and I'm going to change the colour to make this easier to see, a delta negative oxygen and a delta negative nitrogen. So there wouldn't be a very strong attraction there, if anything, or repulsion. Between sulfur and hydrogen, of course, this is going to be delta positive, and between carbon and sulfur, we'd expect sulfur to be slightly electronegative, but very slightly. So there's a slight attraction there in B. If we were looking at C, then we've got this one could be a little bit hard to work out with the hydrogens, but this nitrogen is going to be delta negative. It's going to be negative, making this a positive. And the same would be true here. The oxygen on this end of the bond would be making this negative and the hydrogen therefore positive. So again, we've got this same repulsion you'd expect. And then D, we've got this delta negative nitrogen and a delta positive hydrogen. And this would have the greatest attraction because this has the greatest difference. So if we look at the electronegativity difference between the sulfur and the hydrogen and between the nitrogen and the hydrogen, we can see that this bond here would be stronger. The difference here between the electronegativity values of hydrogen and nitrogen is greater than that of sulfur and hydrogen. Therefore, the answer for this one is going to be D. And then finally, we have question 9, which says of the following, the factor that has the least effect on the strength of a hydrogen bond in a molecule is what? So each of these things that are listed do have an effect on the strength of a hydrogen bond. A says the type of atom to which the hydrogen bond is covalently bonded. Of course, that does matter because it can affect the electropositivity of the hydrogen atom. So we saw that in the last example. B says the distance that the hydrogen atom is from the atom on the other part of the molecule. And of course, that would affect it. The further away they are from each other, the stronger that attraction is going to be. Then C is that the number of other hydrogen atoms attracted to the atom on the other part of the molecule, would that have an effect on it? Well, if you've got lots of delta positive charges around a delta negative, let's say here, then those delta positive charges could prevent this hydrogen from accessing the nitrogen because of repulsion in that one area. It does happen, but it's not a very big effect. And C says the type of, or D, sorry, says the type of atom in the other part of the molecule to which that hydrogen atom is attracted. Well, that is obviously going to have an effect on it, and it'll have quite a large effect, in fact, because if they weren't positive and negative, if they weren't complementary in that way, they'd repel each other. So it's really important that one is positive and one is negative. The one that has the least effect, of course, is going to be C in this case, which says the number of other hydrogen atoms attracted to the atom on which the other part of the molecule. Because, of course, while you can have delta positive other hydrogen atoms here that are trying to block one of them from covalently, or at least forming a hydrogen bond with the nitrogen, it can cause repulsion, and that's how that effect works. But there isn't a lot of room in that small space for that to happen. And so we could say that it's going to have the least effect. So we can say fairly confidently that the question 9 answer is going to be C. So that was questions 5 to 9 of section 3 of the green booklet. I hope that helped.